All right, everybody, now we're going to talk about bond length. Bond length is defined as the distance between nuclei. So if we're talking a covalent bond, we have one nucleus and the other nucleus, and the distance between those two is what we call bond length. And it's actually pretty easy to determine. The larger the atoms, the longer the bonds. All right, so if we have bigger atoms, that means those nuclei are further apart, we have longer bonds. We also have to distinguish between single, double, and triple bonds. And I've used the greater than and less than signs here. Single bonds are longer than double bonds, which are longer than triple bonds. This kind of makes sense though, especially when you take this into account, bond strength. Bond strength is closely tied to bond length. The shorter the bonds, the stronger the bonds, which kind of makes sense up here. A double bond is shorter than a single bond, and a double bond is stronger. Hopefully that you can see how that's pieced together. Here I have several examples of what is the longer bond. That's going to be my question, is which bond is longer, all right? And I've kind of boxed the carbon-carbon single bond up a little stranger, all right? But here first we're going to look at the carbon-carbon single bond and the silicon-silicon single bond. And what you have to ask yourself is what's longer, or excuse me, what's larger as an atom, carbon or silicon? And if you look at the periodic table, silicon is below carbon, therefore it's a larger atom, which means this compound, or excuse me, that bond is longer than this one. Hopefully that settles, pretty easily with you. Here, if you look at the carbon-carbon single, double, and triple, which one is the longest bond? Well, single bonds are always the longest between single, double, and triple. So between these three, a carbon-carbon single bond is the longest. An alternative question is which bond is the strongest? And the strongest bond is going to be the triple bond. Here we have a carbon-iodine bond and a carbon-bromine bond. If you look at the periodic table, you'll notice that iodine is below bromine, which means it's a larger atom. So the longer bond here is the carbon-iodine bond. That's going to be the longest bond between these two. Here we have a hydrogen-oxygen bond and a hydrogen-sulfur bond. Again, if you look at the periodic table, sulfur is below oxygen, meaning it's a larger atom. Because it's a larger atom, this bond is longer, okay? Over here, similar to what we did with the carbon-carbon bonds, here it's carbon-oxygen. A carbon-oxygen double bond and a carbon-oxygen triple bond. Double bonds are longer than triple bonds, so this is going to be the longer bond between those two. Another way to talk about this or ask questions about these is to ask which bond's stronger. And all we have to do is jump back here. If the bond is shorter, then it is stronger. In the next video, we're going to talk about bond enthalpy, which sounds like a big term, but it's actually just how much energy is needed to break a bond. It's very simple to understand. But this is our bond length and a qualitative approach to bond strength.